the mass conversion from grams to kilograms for the velocity raptor. So, first of all, grams equals 5. We got 5 grams. By the way, this is all measuring mass, but so we have 5 grams. Oh yeah, the G represents grams instead of mass, Or I mean, not mass, gravity. So, grams equals 5, and kilograms is what we are looking for. Sweet. And so, to find our kilograms, we take our grams over 1,000, because there's 1,000 grams in a kilogram, because kilo, 1,000, pretty cool word roots. Anyways, so putting this into our equation, 5 grams over 1,000 equals 0.005, right? Yeah. 0.005 kg. So, that means that our answer is 5 grams is equal to 0.005 kg. Alright, that's been our mass conversion for the velocity raptor. So, I'm going to be looking for the velocity at the top of this loop. Okay, so starting with the variables, we know gravity is equal to 9.81 meters per second, meters per second squared. And then we're going to have 2 heights because we subtract the height of the height from the floor to the top of the loop from the overall height of our roller coaster. So our H1 is the height of our roller coaster, which is 1.81 meters. And then the height from the floor to the top of our loop is 1.12 meters. And then our velocity is what we're looking for. So the formula we're going to be using is V equals the square root of 2g, and normally it would be 2gh, but in this case it'll be 2g h1 minus h2, because, as I explained, we have to get the height from the floor, or we have to get the height of the loop. So now we plug in our variables. So V is equal to 2, which is part of the formula, and then G, which is 9.81, and then H1 minus H2, which is 1.81 minus 1.12. And this is equal to approximately 3.68 meters per second. So that's the speed at the top of a loop.
Hello! I'm Saumya, and today I'm going to answer the question, what is the maximum gravitational potential energy of our roller coaster? So first of all, here is a very nice drawing of our roller coaster. Now, potential energy is at its highest when it is the furthest from the ground. And the highest point of our roller coaster is at the very beginning, right here. So we will be finding the potential energy of the marble at this beginning point. So next, I've listed the variables of interest for this problem. We have the mass of the marble, which is 0.005 kilograms. We have the acceleration due to gravity, which is 9.81 meters per second squared. And we have the height of the point, so that the distance of the marble from the ground, that is 1.81 meters. And that's basically the overall height of our roller coaster from this point to the ground. That is 1.81 meters. That's the height we will be using. So now the formula we will be using to answer this question is the formula for potential energy, which is potential energy equals mass times the acceleration due to gravity times the height. So now what I'm going to do is I'm going to substitute these variables into this formula. So for mass, we're going to plug in 0.005. That will be multiplied with 9.81, our value for gravity, which will then be multiplied by 1.81, which is our height. And finally, it's time to solve the problem. So I put all of these numbers in this equation into my calculator, and the result is 0.0888 joules, which is the unit for energy. Therefore, the maximum potential energy of our roller coaster, well, of the marble on the roller coaster, is 0.0888 approximately joules. Hi, it's Saumya, and today I'm going to be answering the question, what is the speed halfway down the first descent of our roller coaster, the Velocity Raptor? So first of all, here's a drawing of our roller coaster, and this question focuses on the first descent, which is right here. It kind of levels out about right there. So we're going to be looking at this part of the roller coaster. So here I have a close-up picture. We're going to be looking at this much. This is the first descent. So this is going to require a couple different numbers that will need to be found. I've listed some of the variables. So gravity is 9.81 meters per second squared. The mass of the marble is 0.005 kilograms. And H1 stands for the height of this descent. It's 0.45 meters tall. So because we're only looking at this part of the roller coaster, we're only going to worry about this height, and we're going to pretend like the bottom of the descent is just like the ground. But the question specifically asks about the velocity halfway down the descent, and so we're going to need to find H2, which is going to be the height of the halfway mark. We also will need to find potential energy at the top of the descent, kinetic energy at the bottom of the descent, and then finally, of course, velocity at the halfway mark. So first of all, let's find the halfway height of this descent. So, because we are looking for the halfway down, all we really need to do, so let's say this is H2, all we need to do is take half of the total height of the descent, which is 0.45 as earlier stated, so like 1/2 of H1. So we do 1/2 times 0.45 meters, and that comes to 0.225 meters. So this distance from the top of the descent to halfway down is 0.225 meters. And because the question only asks about the speed halfway down, we can do basically what we did to the rest of the roller coaster and just kind of ignore this part and kind of treat this halfway down point as like the ground. So we'll be treating this half of the descent as kind of like a total descent. And so we'll say that this is at the height of 0.225 meters, and this is like it's at the height of 0. Okay, so now that we've found out that h2, or the height halfway down the descent, is 0.225 meters, we can move on to find the potential energy of the marble at the top of the descent. So the formula for the potential energy is mass times gravity times the height. So substituting in our values, we know that mass is 0.005 kilograms times 9.81 meters per second squared for gravity. And for the height, we're going to use the height that we just found, so 0.225 meters. And we solved that. I just plugged it into my calculator, and it came to 0.011036. Ooh, that's long. Joules, because that's the unit, for energy. And now that we've found the potential energy at the top of the descent, we can find the kinetic energy at the bottom of the descent. Now, because of the law of the conservation of energy, we can say that the kinetic energy at the bottom of a descent will be the same as the potential energy at the top of the descent. So we'll substitute in our value for potential energy. So basically, the kinetic energy at the bottom of the descent is the same as the potential energy at the top, which is 0.011036 joules. And now, finally, having found all of our remaining variables, we can finally go on to the final piece, finding the velocity. So the formula we're going to use to find this velocity at the halfway down point of the descent is the square root of 2 times the kinetic energy over the mass. So I substitute in 2 times 0.011036, that should be longer, over 0.005 for the mass. And that comes to about 2.1010 meters per second. So the speed of the marble halfway down the first descent is 2.1010 meters per second. Thank you.